In a White House announcement early last week, U.S. President Donald Trump startled space scientists by issuing a directive announcing a U.S. intention to return to the moon and other destinations. "This time we will not only plant our flag and leave our footprint," he said, "we will establish a foundation for an eventual mission to Mars and perhaps someday to many worlds beyond." The announcement drew support from NASA, aerospace proponents, and Congressman Lamar Smith of Texas, who chairs the House Science, Space and Technology Committee. "This administration's dedication to space is a refreshing change from the past 8 years," said Smith. Even SpaceX CEO Elon Musk, who parted ways with Trump last summer over climate change, tweeted his approval. "It's high time that humanity went beyond Earth," he wrote. But not everyone is as sanguine. Many Americans view their president as flighty, lacking on follow-through. And Robert Zubrin, president of the Mars Society, points out that when John F. Kennedy announced his dream of putting a human on the moon, he did so in a speech before a joint session of Congress, not in a lightly attended press conference. "There's no evidence whatsoever of any serious commitment," Zubrin says, not to mention that it is far too early to know if Congress will even fund the idea. If the proposal does turn out to be taken seriously by both the Trump administration and Congress, however, Zubrin is supportive, even though his organization's long-run target is Mars, not the moon. "The moon," he says, "could be a useful testbed for spacecraft designs and other technology ultimately designed to reach beyond. And," he notes, "it's only possible to launch for Mars once every 2 years. In the interim you'd be idle. So you want to do the moon and Mars in parallel." David Kehring, a lunar geologist at the Lunar and Planetary Institute, in Houston, Texas, agrees. "The moon," he notes, "is only 3 days away, which means it's possible to go there many times in fairly rapid sequence. We can fly there, realize something's not quite right, fly again, and test a modification," he says. "The first trip would begin," he says, "by launching a pair of rovers to the moon, each capable of housing 2 astronauts in pressurized environments. Once the rovers are safely landed, possibly as early as 2030, the astronauts would follow. They would land nearby, walk to the rovers, explore for 14 to 42 days, and return to the landing site. The rovers would then be remotely driven to the next landing site, conducting robotic science observations along the way. It's an elegant scheme, with landing sites already recommended based on orbital surveillance. The imagery is so good that we have half-meter resolution," Kehring says. "In some cases, we have even identified rock samples we would like to be collected. The most likely destinations," he says, "would be on the lunar far side, in and around Schrödinger crater, a 312 km impact basin not far from the lunar south pole. One of the things that make Schrödinger interesting," he says, "is the presence of a volcanic vent that once spewed lava that may have contained volatile elements. These volatiles may still be on the moon, preserved in permanently shadowed coal traps even closer to the pole, where they might be usable for fuel and air. We want to understand the amount of volatiles in the lunar interior," Kehring says, "and their transport once they have been liberated." Schrödinger also has a mountainous peak ring in its center, formed of rocks uplifted from a depth of perhaps 20 kilometers beneath the surface. These rocks, Kehring says, may offer clues to the earliest eras in the moon's history, when its surface is believed to have been covered by a magma ocean. Also important is the fact that the crater appears to have been formed at the end of a period called the Late Heavy Bombardment, when an onslaught of asteroid or comet impacts are thought to have formed most of the moon's largest craters in rapid succession. If such a bombardment happened on the moon, it also happened on the Earth, and understanding it will offer windows to ancient epochs long since erased by erosion and other geological processes. On Earth, we have no record of the first half-billion years, but it's waiting for us to extract from the moon's surface, explains Kehring. That's the period when life evolved on our planet. If you want to understand the early evolution of life on our planet, you need to look at the lunar record for the processes that were affecting Earth at the same time. Much of the technology to send astronauts back to the moon already exists," Kehring says, "with one important exception. We do not currently have a lander suitable for delivering them to their rovers and returning them to Earth." Francis Nimmo, a planetary scientist at the University of California, Santa Cruz, agrees. "NASA will have to redevelop technology for landing on a body with gravity," he says. He also cautions that if we want to go on from the Moon to Mars, we need to realize that the 45-year gap since the last Apollo mission has taught us that time can erode expertise. Don't wait too long between the Moon and Mars, he says. Also important, Nimmo and others say, is to create public excitement for a resumption of manned space exploration beyond low Earth orbit. Perhaps President Trump's proclamation will help. But years ago, the original Star Trek fired the imaginations of an entire generation of space scientists. Perhaps, Nimmo says, we need more books and movies like the 2015 blockbuster The Martian, based on a book of the same name by Andy Weir. I suspect that particular Hollywood product has done more than almost anything else to create public interest, Nimmo says. It would be interesting to compare the number of people who saw the film worldwide with the number of NASA TV viewers. Weir, whose latest book is, ironically, set on a moon base, is flattered but humble. As a writer, my job is to entertain, he says. But if it has the side effect of increasing public interest in science, I'm thrilled to see things play out that way.